Okay, how do we represent valence electrons with dots? We've talked about how to identify the valence electrons. These are the ones in the outermost principal energy level, and they are the ones that are most loosely held because they're farthest from the nucleus. So those are the ones that participate in bonding, and so those are the only ones we're going to look at when we're doing Lewis models. So to make a Lewis symbol, we're going to put the electrons, the valence electrons, we're going to show them as dots around the element symbol. So here we're going to draw the Lewis symbol for oxygen. So we're going to start with the element symbol for oxygen. It's O. Then we look at the periodic table to find out how many valence electrons does oxygen have? 6, because it's in group 6A, right? So we can tell pretty easily, you just look at the group number at the top. Fluorine's got 7 valence electrons, oxygen has 6. And then we're going to put those electrons around, see if my dot size is right. A little big. We're going to put those electrons around this element symbol. So we have 6 electrons, so we're going to have 6 dots. Ooh, fancy, right? That's the Lewis symbol for oxygen. To make that easier to look at so that we don't have to get our finger out and count the dots, we're going to put the dots on the top, the bottom, the right, or the left, so 4 sides, like the points of the compass, and we'll have at most 2 dots on each side. Okay? And this gives us a simple way to visualize the number of electrons. It's a little bit like looking at a pair of dice, right? And if you see this configuration, do you need to count to know how many there are? No, that's 5, right? And so for electrons, when we see that there's 2 on each side, we can know without counting them that there's 8. So that might be something like argon with 8 valence electrons. Okay? So atoms that have 8 valence electrons are said to have an octet. An octet in music is 8 people singing together, right? So here this is 8 electrons. And this is a particularly stable situation, which is why atoms like to do things in order to get 8 valence electrons. The noble gases all have 8 valence electrons. And we've learned how atoms gain and lose electrons to become ions that have the same number of electrons as a noble gas. They also then have 8 valence electrons, except, of course, for that little guy, helium. Helium's too small. Helium's happy with a duet of 2 electrons. But what we refer to as the octet rule, atoms will transfer or share electrons to achieve an octet of valence electrons. So when we're drawing Lewis structures, we're basically looking at, well, how many valence electrons do we have from all these different atoms, and how can we arrange these guys so everybody can have 8? And sometimes a lot of sharing has to occur.